Another important concentration term we will encounter this year is part per million and part per billion. So basically part per million means one part per million part of solution. So you can say 1 gram per 1 million gram of your solution. It has to be in the same thing, so it's gram per gram. But if we are talking about aqueous solutions where we are using water and there are very diluted solutions, then we can consider now the density equals 1, and then instead of using gram we can use milliliter and liter for the solution. So part per million is going to be instead of using the mass of the substance or mass of the sample, it's going to be mass of the substance over the volume of the sample. And then for part per million, it will be 1 to 2 billion part of the sample as well. So part per million can be also expressed as milligram per liter or microgram per milliliter. So it's equivalent to 1 to 1 million. Um, that's if the density of the solution is 1 gram per mil. Part per billion is microgram per liter or nanogram per milliliter. So for example, if an aqueous solution has 1000 part per million in copper, that means it has 1000 milligram of copper per liter of the solution. And if it has, or we can say it has 1000 microgram per milliliter of solution. I hope you understand why the part per million is milligram per liter, because basically 1 liter is 1000 gram, and 1 milligram um, per liter means 1 part per million part of the solution. Okay. So let's see an example to see how can we convert a concentration from part per billion or part per million into molarity. So a question here about the normal alkanes, which are hydrocarbons. So an alkane that has a molecular formula of C296H60 is collected in the summer rainwater, and the concentration was found to be 34 parts per billion. And we need to find the molarity now. So we need to change the concentration term from part per billion into molarity. So the first thing you need to find is that you need to know that 34 part per billion equals, as we said, or it means 34 nanogram per ml of the solution. This is because the density of the rainwater is close to 1 gram per milliliter. And to find the molarity, we need first to know how many grams of that hydrocarbon C29H60 are contained per liter. So the first thing also to know that the 34 part per billion means not only 34 nanogram per mil, but it also means 34 microgram per liter. So if you multiply both by 1000, or we can say it equals 34 times 10 to the power minus 6 gram per liter. So this is how much um, of this hydrocarbon do we have per liter of the solution. Then let's find the molecular mass of the hydrocarbon. So the molecular mass will equal 29 times 12.011, which is the atomic mass of carbon, plus 60 times 1.008, which is the atomic mass of the hydrogen. So this will add up to 400 408.8 gram per mole. Okay, so now we know the molecular mass of the hydrocarbon, and we know the concentration of the of our hydrocarbon as well. In order to find the molarity, so the molarity here will equal 34 times 10 minus 6 gram per liter divided by the molarity, the molecular mass, which is 408.8 gram per mole. So the molarity will equal 8.3 times 10 to the power minus 8 molar. Okay, so instead of using 10 to the power minus 8, we can use molar. We can use one of the prefixes, which is the nanomolar. And we know that nanomolar is in that 1 molar equals 10 to the power 9 nanomolar. So if you multiply this times 10 to the power 9, we will end up with 83 nanomolar. Instead of using molar and using the 10 to the power minus 8, we can use the nanomolar. So the molarity now is 83 nanomolar. This is how you can convert the part per billion into molarity. If you have it as part per million, then instead of using nanogram per mil or microgram per milliliter, it's going to be milligram per liter, and you will continue in the same way until you get the molarity.